Alright, I hope everybody has their wireshark installed and understands what it is, but this lab that we're going to do for the security is in regards to DNS traffic. It's an open source packet capture analysis tool, so we're going to focus in on identifying things that could be a problem. So it allows us to view packet details that can be used as a reconnaissance tool for an attacker. In this lab, we're going to use it to filter DNS packets and view the details of both queries and responses. So I've got the lab open. It shows you the wireshark. You should have a network adapter that's got activity on it. In my case, it's my Wi-Fi. I'm going to double click on my Wi-Fi adapter. We should start seeing data flow. All right. They want us to open up the command prompt and flush DNS, which we'll still do, and then we're going to perform some nslookup so they can key in on what's going on. I have some active apps in relations to security that are doing some data analysis. For one, I'm actually filtering packets. I'm monitoring what is going on the machine, and then that way I can kind of head off a problem before it becomes a problem. So I'm constantly going to have some traffic. So from here, we're going to run the ipconfig/flush DNS. And then they're going to use a tool called nslookup, which is basically a DNS client. All right, so nslookup is going to let us move this over here, run these commands right here. nslookup. We're going to punch in cisco.com. Now I'm using Google's OpenDNS 4.8s because they do a pretty good job of vetting. I also use level 3, which is a 4.2.2.2. If you punch that in and press enter, you'll see that that's a resolver level 3. This is another DNS that I use as a backup. Both big internet DNS providers. So let's go in here and let's type www.cisco.com. Press enter, just like the lab was requesting. See, we get back the same results. We're getting to commieedge.net. I think if you do a search on a Commie Edge, you'll find out that they're a huge player inside of security. We're getting the aliases for it, so you can see that cisco.com, aka dns.net, edge-key, some other certs. These are their global IPs for their website, cisco.com. So you got IPv6 and IPv4, so they've already moved forward and have both available. So as soon as we're done with this, we need to go over here and stop the packet capture. And then it says explore DNS. So DNS actually uses multiple ports, but we're going to key in on the UDP. So we're going to put a filter in. So I'm just going to copy that from the lab. We'll go back over here to my wireshark, and I'm going to paste in that UDP. So again, I got a lot of things running in the background, and all of us do, so you may not just get the Cisco, but we're looking for a packet that's labeled standard query with www.cisco.com. So you can see Office Apps is running in the background. I have Teams for Campus, it's running in the background. We got reverse pointers. Oh, here it is, Cisco. So we're looking for the 002. See a 3. Did I miss it? So it's kind of funny. So that fec.local is my domain controller that's in the office, and it's appending the local domain of Active Directory onto the web domains. Sure what happened to the 002, but I'll just key in on the 003. Alright, so in the packet details pane, notice that Ethernet 2 IPv4 user datagram protocol is called a query. So let's see if we have a query. What is a query? You can say domain name system, DNS is the UDP 53 service, and you can see that this is a query. What were they querying? We were querying cisco.com. So just so you know, when we query a name is referred to as a record. So I'm going to have to type A, and it's M. We look at the Ethernet 2 details. It says observe the source and destination fields. All right, so let's go back up here. The Ethernet 2 section. So the destination, just so you guys know, since this was a query to cisco.com, is my firewall. I use a product called Fortinet in my offices. It's actually FortiGate is the actual appliance, but Fortinet manufactures it. So we're going to have a Fortinet MAC address, because remember, your router or your firewall that's in between you and the internet is where your packets are going to go. We're not going to see the actual Google DNS or the full query. And your answer may be a little bit different because everybody's going to have a different router. If DNS was running on the inside of the network, it would look a little different. But the destination MAC is going to be a remote MAC address of your gateway. And then this is the internal MAC address of my wireless card, Intel wireless card. Let's see what they have here. So you can see that this was done at somebody's location where they had a Netgear router. And then this is their internal card. So what are the source and destination MAC addresses? So you can label them based on what you're using, but the network interfaces that are associated with the MACs should be your network card on your router, the MAC address of it, and the MAC address on whatever card you're sniffing. In this case, my wireless card. All right, so that says let's look at Internet Protocol version 4 and look at the IP addresses. So if we shrink that and open up the Internet Protocol 4, it was my local IP address of my machine that's sending the query. And where are we sending the query? We're sending it, in my case, to Google, because that's what I've got specified as my DNS. This IP address should be whatever you guys are using. So if you're on Comcast and you haven't changed anything, it's probably a 75, 75, 75, 75. If you're on Southern's campus, it's going to be some 131.95 number. So the destination IP address is going to be whatever the IP address of the DNS server that's handling our query. What are the source destination ports? Default DNS. So the source port is going to be different than the destination. The destination can't change because it's fixed. When we're talking about DNS as a service, DNS uses both TCP and UDP 53. In this case, we're keyed in by the filter on UDP 53. But the source port is going to be randomly generated. So remember, almost anywhere and everywhere you go, because of the IPv4 address limitations, we use NAT. And NAT creates a dynamically changing port number. So in this case, my source port is 55896, and that was created by my FortiGate firewall and handed to me. And what that does is it allows me to use 7293 to make a connection to 8888 on DNS, and then get back and forth between me and them. Because just as my machine's doing this, there's about 40 or 50 other devices inside of here. If you're on campus, there's thousands of devices that are all making queries to DNS at the same time, and each individual station has to have its own port to make that query. All right, otherwise we wouldn't be able to get stuff back in, and they're constantly changing. So that's why the source port looks weird. It says open the command prompt and run an ARP-A. So we're going to look at our ARP cache on our actual machine. Remember, if we're talking about a switch, the switches use MAC address tables to move things around the LAN. They're LAN based only. but our routers and our PCs use ARP to maintain an IP address to MAC address mapping. Now, the MAC addresses that we're going to get back are going to be the address associated with the gateway. And I've got a bunch because I've got all these virtual adapters for all these different machines that I use in research and testing. But we're looking for the 192.168.72 network. Where are you at? Go right past, here it is. So this is the network. My MAC address that was in the wireshark earlier is going to be this because that's my gateway address. And then my own MAC address would be in here as well. So the 7293 was the other one that we pulled from. And to see that, I would do an IP config. So that's what they're showing you here. Expand the domain names, query, and then look at the query data. I already kind of pre-did that before, but you can see that there are flags that get set when we're sending as we're translating and getting responses back. And then they're going to have you move around and look at the different packets going both directions and how it kind of changes. So you can key in on a response. And what the response is going to give us is the actual Cisco.com domain and the IP address associated with it, which was all the data that we saw in the nslookup window. Let's go key in on that. We're looking for the response now. And so this data right here under the answers, you can see matches what we were requesting from Google. Here's the initial query. You can see that there were several responses. The IP addresses. That was for Google. So this was in, I have my web browser open with my Google account. So that was a query response for accounts like Google. You're logged into your Gmail. All right, so everybody should see that you can get responses for both IPv4 and 6 in regards to DNS and what we're querying. And then it says, how do they compare to nslookup? Well, they should be pretty close to the same. All right, so you've seen how to use Wireshark and capturing DNS. This is extremely important because, again, if we have a machine that's acting up and we want to know what's going on behind the scenes, all right, malware, virus, rootkit, some application gets installed on the inside of our network on a device, all of those things aren't going to just be right there in your face. They're going to be hidden, but they're going to be making connections outbound. And a way to identify where they're going is with the DNS queries that are happening from that station. So we can do a packet capture and lock in on the addresses that are coming in. And then we can take and use nslookup or another tool to query those IP addresses and find out what our device is doing and kind of figure out which servers are being used to control, encrypt, or other functions to systems on the inside of our network. The DNS is very important in regards to security and being able to track down problems.